Hello Internet, this is Bill Jamison and this is my first process video on CNC sculpting of organic shapes. Today we're going to be going over this piece here, which is a cup holder with an aluminum interface that connects to a found rock. I thought I'd start off with just a general sample of the work I do. I'm a mixed media sculptor and I'm interested in combining organic objects, things with a lot of crunchy, gnarly angles and natural beauty with milled and designed, really slick powder coated elements. So it's just a general overview of some of my work. You can kind of get an idea of what I'm interested in. Today we're going to be going over a brief overview of this demo piece here. I picked it because it's got a little bit of everything. It starts off with this found rock base here, and it's got some porcelain cups and a powder coated aluminum interface, along with it's also got a aluminum wall bracket on the back. So it's probably the most complicated piece I do. So just to kind of show you how this thing goes together, we'll take it apart. The main portion comes off the wall bracket like so, and the aluminum interface is held in with a series of little stainless steel hex socket screws. So those are connected to the rock with some embedded anchors. So we'll just unscrew this here. I already did some of them, but just might take a second. I used a lot of screws on this one just because I had the room. It's probably more than you need, but I also think they make a nice visual element too. I mean, because to me it's about that industrial look paired with nature. So we'll take that off and you can kind of see the rock portion and the anchors, and then we'll take apart this wall bracket. It's got a couple of 1/2-inch rods here that are threaded on to some 1/4-inch bolts, and then it's just got some screws that hold it to the wall. So pretty simple wall bracket, and we'll be modeling all of this. I just thought it'd be nice to kind of see how everything fits before we go into. So if I'm making a piece that has ceramic elements, the first step in my process for making these multi-part pieces is casting the cups. And slip casting is a process of pouring liquid clay into a plaster mold, and the plaster draws the moisture out of the clay, develops kind of a hard, thick shell, and you pour the liquid clay out, and you're left with a ceramic copy. So for my pieces, I've got the finished product here, which was based on a carved plaster positive, and from that I made a plaster mold. So I've got several of these molds, several positives, several molds, and from that I can make a wide variety of shapes and sizes. So again, mold making, it's a process unto itself. Hopefully I'll make a video on that. There is a lot of good resources though on slip casting and mold making, and I would definitely recommend, if you're getting into it, this book here, Mold Making and Slip Casting by Andrew Martin. It's kind of the Bible on this, at least in America. So the other part of this initial process is finding and preparing the organic piece. So finding a rock or a crunchy piece of wood, I'm really looking for some depth and complexity and something that's formed naturally to pair with those really designed and polished slip cast cups. And I need a flat surface. This piece actually, it already kind of was flat, so I didn't really need to cut it, but if I did, I would use this angle grinder with a circular diamond cutting wheel, and then you can come back with a diamond cup attachment to really clean it up. And then finally, to make the holes, it's a diamond hole saw that also fits in that angle grinder. Really high RPM on all this stuff. Chips come up, so make sure you've got a respirator for all the dust and also eye protection. With all this preparation, it's really important to have a nice flat surface because I'm going to be scanning it in, and I don't want any gaps between the aluminum interface and the rock. So the tool I'm using to make sure it's nice and flat is a flat lap. Once I've kind of roughly ground it down, I come back with this really high-speed diamond wheel that's got water to cool it, and I grind it down, and that creates a nice, almost glassy surface. So now that we've got our physical objects, we've cast our cups, we've ground and prepared our rock, and maybe played around with layout a little bit, know where we want everything, we're going to bring it into the digital world, process called digitization. It starts with scanning the objects on a flatbed scanner, bringing those into Photoshop to kind of clean up that raster JPEG image, and then bring that into Illustrator to create a vector, which can then be read by Fusion 360, our modeling software, which will eventually get into tool pathing for the machines that'll cut it out. So for this portion of the tutorial, we'll be working on the computer, and here's the piece that we're using as an example. Unfortunately, you might notice we're in Illustrator. I lost the Photoshop step on it, so we're going to use another piece. This one here, it's pretty similar. It's also got holes, as you can see, and a couple of cups. And now we're in Photoshop. So this is a flatbed scan. Again, just a normal, like you would copy a piece of paper on. And the nice thing about a flatbed scanner is it actually brings everything into scale. So I don't need to worry about that too. So what your images are from the scanner, even though I scanned it at a very high resolution, 1200 dpi, and you can zoom in and you've got great resolution, but it's still actually pixelated because of the inherent type of file it is. It's a raster image made up of a bunch of little small squares. That is not something that a computer CNC equipment can be controlled by. They need a defined path of line work. So the first thing we're going to do is we're going to define where the flat area is that plate is going to sit on, that aluminum interface. So you can see I've kind of painted this white where I want the plate to go, where I want it to be cut out. And so to further define that, I go in with a brush tool in Photoshop and I actually outline the whole area. And since we are in Photoshop, even though it seems very solid, it is solid black, but the edge here is still jaggedy, and that's still something that CNC equipment can't follow. So to zoom out here, we're going to turn off the image. So now we've got basically a very nice high contrast image to bring in Illustrator. I've deleted everything that isn't that flat surface, and everything that I do want I've made black. So basically it's black and white, super high contrast. So we're going to save that as a JPEG in Photoshop. So instead of a Photoshop file, just save it as a JPEG, and then I'm going to open that in Illustrator, so right here. So I've got this file, and what I've done is I've live traced. So that's the beauty about art software, is it's kind of designed for these complex shapes. I could actually have brought that photo right into Fusion 360 and kind of outlined it with straight lines, but it probably would have taken me forever because it's such a complex shape. But this image trace software, I can start with a photo and actually so this is, we'll turn off the scan. This is what I'm sorry. This is the photo, and then I brought in the black and white Photoshop file that was pixelated, and I did an image trace using this tool here, and now I've already traced it. And if we zoom in, you can kind of see these are actual straight lines. It'll be easier if I go into a wireframe. You can see these are just grips here, little points that can be, let's just pick one of those, drug and moved, and this is actually what defines the edge of the shape, not a bunch of little squares, but actual mathematical curves and points. So that's what Illustrator does, is it converts into that, and then we're going to send this into the modeling software. And as you can see, there's actually thousands of these little points, so that's where I say you could do something like this. If you had a simple shape, you could just take that that image, and you could actually just trace it in Fusion 360 if it was simple, but you'd have to draw basically short little lines between all of this, and it would take a very long time. So Illustrator's image trace software makes that a lot simpler. So we're going to open up Fusion 360, and I'm going to skip ahead because my computer is very slow, and it's going to take quite a while to open that up. I'll probably have to close Illustrator and Photoshop too because I have an older computer. Now we're in Autodesk Fusion 360, and I'll just do a quick overview of how this modeling came together. So this first thing here is it's an SVG that I exported from Illustrator. So you can kind of see it's my starting point for that rock. And I'll zoom out, and this square here is just a scale. For some reason it imports not quite to scale, so I have to make a little 1 inch by 1 inch box to kind of get that going. But then it's got all the bolt holes from the scan, my little name thing there, and the cups and the outline of the rock. So just skip a few steps forward. So obviously the first thing is extruding that rock outline. You can see it's really complex because it's got all those edges, and coming through and extruding one by one each of those rings and offsetting them, making a little inset so that they hold the cup securely. And so these are all just extrusions. It's pretty basic, really. The hard part when we get into the detail is figuring out like the settings, and it's kind of on either end of it. The modeling of it, extrusions are pretty easy, but getting your file formats right to bring it into Fusion is a little tricky. And then also the cam stuff, something I wasn't as familiar with. So I'm also creating these little tabs here for the bolts. They're not necessary. It's more, this also is still more kind of almost an aesthetic element, just to create that kind of, I'm looking at like engine blocks and things like that have these kind of raised ridges, combining the outline there, make kind of a cool shape, cutting the holes. And then that's pretty much it for this aluminum interface. Now I've got like my 1/2 inch bar for my back plate. Bring those two in, and actually, see, they have holes cut in them into the aluminum plate there. And then I've got my mounting plate, which I've sketched out, and so I laid these rods just out on what looked good to me, and kind of just created the borders and spacing of everything, just kind of. So there's one of the screws I used. I imported some parts from the master car catalog. So this is just a 1/4 inch hex screw. So if I take the back plate off, you can see it just threads into that rod, and I've created a little socket. I don't know if that's clear. You can look at this one that doesn't have a screw in it. So it'll hold the head of the screw, but it won't let it turn. So that I can mount the plate onto the wall with these little the screw, but without the rods, and I could put the rods on afterwards to make it easier to screw the back plate to the wall. Let's finish this out. So now it's got all the screws in it, and it's pretty much ready to send to cam. So going from the modeling environment to the cam environment. So all of my toolpaths. So basically each of these components has at least one setup, and so you've kind of got to break it down part by part. So we'll just turn off everything but the rock, for example. And so just using it as an example, it has a setup I've got called main machining here. I'll make it active. So this is the block that it's machined out of. And let's take a second here to bring up these tool paths. Every time you change the model a little bit, turning those things on and off, it needs to recalculate the tool paths. It doesn't trust that nothing changed. So okay, but so now it knows what's going on. So these are all my tool paths for this. It seems like quite a bit, but we can run a quick simulation that'll make it maybe a little more apparent. The tool path, I think that's kind of confusing to see all that. I think it's more clear just to see it as stock. And we should be able to play, and let's just pause this real quick and turn off the sketches. Just focus on the model. So we can speed this up. So this is a facing operation, kind of getting the top nice and smooth, and it comes in, does some rough milling with a bigger bit, goes in, kind of working on the fine details. So in the other video I'll go on into what tools I selected and I need to do all that. So what you see here is I've got all the mill work, but the actual rock outline isn't cut up, and that's cut out, and that's because that's done on a water jet. So I've got a couple CNC tools I use for these. I use the mill anytime I've got raised surfaces like this, contours, but a mill couldn't get in and do these fine details because you've got to have, you need a really thin tool, and it would either break or just not have a tight enough radius. So a water jet is actually the tool we use to kind of trace that rock outline after all of this work is done. So the other components, the back plate, the rod, they all have similar setups. So again, a setup is just it's when you're putting a piece in the mill, a piece of stock, and so you can have multiple setups for the same piece. If you've got to orient it horizontally, vertically, and I believe this piece has 2 setups on that face. So real quick. Alright, so you can see this setup here is basically the mill. You saw how it was oriented to mill out all of these contours, but then we've also got these holes on the back, and since we're dealing with a mill that can't rotate the part, you've actually got to take it out of the vise and flip it upside down in more of a that kind of orientation. So that would be the second setup, to drill those two holes. Again, so in cam, this setup here. So that's facing it right there, and then coming in and drilling those holes on the side. So this one piece had two setups. Some pieces only need one setup, but you need at least one setup, and sometimes you need multiple depending on what's going on. So that's drilling it right there. We'll speed it up and drilling the next hole. So now we're back in the real world, milling out these aluminum blocks on a Tormach CNC mill. So I've got a few still shots here. It's all flood cooled, and it uses various cutting tools, kind of like a router. And hopefully I'll have some videos on that. And then CNC water jet to get those really fine outlines. This particular model's a really big bed. It can cut through like 6-inch steel. Super high pressure, super powerful, super accurate, really cool, just a little expensive. And then finally they're finished with powder coating, sprayed on powder, which is baked in an oven to get this finished product. So thank you for watching. Please visit my site, billspots.com, and you can also contact me on there. There's a couple other process videos, and let me know if you have any questions. Thanks for watching.